In this class, we will learn how to find the volume of a sphere. Now, imagine you are given a circle x squared positive y squared is equal to a squared. If you were to draw the circle would be something like this. The radius will be from negative a to positive a. Now, you are able to generate the sphere if you can rotate the semicircle, the top side, about the x-axis. So this is the x-axis and the y-axis. Now, if you were to write y in terms of x, then you would have something like this: a squared negative x squared, which means y is equal to square root of a squared negative x squared. So this is what you would have. But we don't need this. The reason is the required volume, is given by a formula which is pi times integral within the limits y squared times dx. Of course, the limits has to be from x is equal to a to x is equal to b. Now, since this is the required formula, our job becomes very simple, because we have to just substitute pi times integral. The limits are negative a to positive a. So negative a to positive a. Y squared is, use this equation, which is a squared negative x squared times dx. Now this is an even function, so we can rewrite this as 2 times pi 0 to a squared negative x squared times dx. Now if I were to integrate, this is going to be 2 pi of a squared times x negative x to the power 3 divided by 3. The limits are 0 to a. Now if I were to substitute the upper limit, it's going to be a squared times a negative a cubed divided by 3. There's no point in substituting the lower limit. It's going to be 0. Now this is rewritten as 2 pi times a squared times a will give you a cubed negative a cubed divided by 3. I take the LCM and rewrite this as 3 times a cubed negative a cubed, which is again rewritten as 2 pi times 2 times a cubed divided by 3, which is nothing but 4 pi a cubed divided by 3. This is the famous volume of the sphere equation or formula, and you have to rewrite or write here as cubic units. That's important because we are dealing with the volume. Without the units, the solution is not complete.